I'm at a thicket wide plot. So that's an experiment that was set up in 2008-2009, 50 by 50 meter plot, put in the landscape and unrooted truncheons, put in with various treatments. And so this is now 2023. We're more than a decade on. And the landowner here has taken down the fence, and so you can see where the original fences were. And this is an active goat farm. You can see the sheep in the distance there. Those look like sheep, not goats. You can see the flock of them out there. So it's in a different camp, but they definitely come into this camp. And I think they do high intensity browsing here. There's no, there just seems to be a little bit of growth. But the crucial thing is, you can see just how many leaves get stripped off. And there's even a bit of ring barking that's happening there. And so what I'm interested in is the leaf litter production. And I've shown you other videos where there's lots of leaf litter. And if we come and look underneath here, there's very little leaf litter that's going on. Yeah, there's a little bit over there. And I think that's mostly because the leaves get eaten before they can fall and form leaf litter. So I'm quite surprised at how little leaf litter there is. There's also, this is quite a steep slope, and you know, here's that creeping form that we want. This is the creeping form that actually starts stabilizing the soil, and it's quite a steep slope. You can see the angle of it there. But because of the form of browsing that's been going on, we're losing that skirt. And you can see that upright truncheon remains. So this is a classic Stuart Hill 1992 paper where he describes this. And you can just see all the leaves, all the side branches stripped off. It's not doing its magic at all. So the browsing intensity here is definitely far too high. I'm impressed that it doesn't look like there's been much mortality, but this thing's not doing its ecosystem engineering processes. You know, this is quite a large plant, and it should have been accumulating carbon, and it's nothing. Any leaves that it may have dropped have washed away. It's not storing any soil, much soil. Whereas this plant up here, here we should still have some leaf litter. There must be something in here. Yeah, look there. There's a little bit of leaf litter. It's been mixed in with the soil. A lot of it's been. So this has been hidden by soil accumulation, where I think a lot of the other plants has been lost because it's just been washed out and washed into the landscape. And so it's changing it to. It's not doing that closed system. Not creating a closed system, which I've discussed in other videos. Yeah, I'm going to follow this thicket wide plot with interest to see how it does with continuous browsing and no fence. I'd like to find out when the fence was taken down. You can still see that even though there have been some good rains in parts of the landscape, this farm has missed it. You can still see how dry it is. This was all mesembryanthemum. It's an annual succulent that comes and goes. The Euclea undulata is still looking good, looking terrible. The Papia capensis is kind of looking okay. Scotia afra has taken some knocks. Yeah, in short, really tough farming out in these landscapes, I think. And this is very nourishing food when in tough times. But how do we get it so that it's sustainable and we're not knocking it backwards? Because as soon as a plant becomes like this over here, I mean, it's just really, it's not creating its own microclimate. It's really suffering. And here's the new growth. This is the new growth from this season, based on this plant. Whereas you can't see any new growth on this plant. Here's some new growth. You can actually see the plants that are stressed. So obviously after the browsing happened, because otherwise this would all be gone. After the browsing came through, bit of rain, this came through, this plant over there, after the rain, without having the skirt, that's the new growth there, after the same rainfall event. No skirt, a little bit of skirt. Let's find one that's got quite a big skirt. Let's see if my hypothesis is correct. Okay, here's some plants with nice big skirts. Here's those red stems. This one's even tried to flower. Yeah, there's another one, big red stem, nice big skirt, nice big skirt. That's all the new growth from the last rain. This plant over here really doesn't have much. Okay, there's a tiny bit of new growth there. Come on, focus please. A little bit of new growth there. That's the new growth on that section there. This one's also tried to flower. That's only the new growth there. So I mean the new growth is averaging around about there. Come over here. That's the new growth there on this plant. That's the new growth there. So just being able to have them, allowing them to make sure that they can form the skirt, means that these plants can just grow so much faster and so much more biomass, which, you know, animals can come and eat this later. You've really got to focus on making sure that you, whenever there's browsing going on, that's only of these thin branches. If you just look at the ratio of the thick branch to the thin branches, these ratios are really skewed. It's from a very thick branch directly to a thin branch, very thick to very thin. Here we should have, you know, that's actually just a continuation. That's the previous growth that's been allowed to expand. And if you just look at the ratio of the size of that branch to the attached offshoot branch, you know, that ratio is quite, you know, it's not a very it's kind of a medium branch to a thick branch, rather than an entirely thin branch to a very thick branch. Yeah, so, you know, obviously the browsing has been quite varied across this plot. For the most part, plants are looking really bad. Some of them are still skirting. That's good news. And I think part of the reason why is because we're on this very steep slope. So the plants that are higher up get protected from herbivory, just because herbivores, it's a high energetic cost for them to get up there. Whereas the stuff that's lower down, much lower energy. So, you know, we find this pattern over and over and over again. As you get lower down the slope, you get more and more browsing. Difficult to imagine that thing over there was once a very, very happy spekboom. I can guarantee you it probably went out, had side branches going out much further, and the goats have just come in. Goats, maybe sheep, but I think primarily goats have just come and clapped it. And there's hardly any leaf litter there. Come on, focus please. And you can just see that branch ratio. I mean, yeah, that's the growth from the last rain that happened here. I was showing you up. Come on. I was showing you up the top there. There's about that much growth. That's what's happening on this stressed plant. And you can just see, because we're low down the slope, this is what happens. And this is what starts knocking these plants back and actually going to cause them to die back. You know, and the plants actually die. I mean, just look at this. You can see this plant was actually rooting outwards, and we just got the skeletons left. Every single, you know, this guy was rooting outwards the side and branching, and that's the normal kind of growth pattern, that it expands sideways like that. And here is a plant just been decimated of every single leaf. Every leaf got taken off here. Absolutely crazy. You just look, and these are just the lower slope ones. Here's one that escaped. I always find it bizarre, like why is that one like that and the one right next door to it like that? So you've always got to look at the average of what's going on, because there always seems to be exceptions. Yeah, so here's a plant that for some, maybe it tastes different, who the hell knows, maybe it had enough energy to produce some tannins to make it taste nasty, so that it went so that the goats went somewhere else, maybe. And because of that, and because it's got a bit of a skirt and it's trapping some moisture, just look at how long there's the red stem. That's the growth since the last rainfall event. That's what it's doing. It's putting on biomass. I mean, there's a lot of evidence still browsing here. I think this has been done after the goats were put in. This little bit of browsing, this is probably done by Dacre. Actually kudu, that's a kudu browse. You see that long what's been left there, that little tail, that's when kudu have been browsing at it. So this is after the goats have come in, the kudu have come in afterwards. Alrighty, some good news. I mean, look at this landscape. So this would have been wall-to-wall thicket in the 1820s, and it got completely decimated. Now we've got the thicket-wide plot showing that restoration's entirely possible. None of this would have happened had they not come in and put in those unrooted truncheons into this landscape. It looks far more impressive from the air, by the way. I might put that into the video. But then we're getting the, how do we prevent this from happening? This is like real discussions that we need to have answers to, because otherwise, how are we going to restore this landscape? And it's tough. Farmers need to earn money off their land, otherwise they can't stay on the land. But all of those slopes should have been thicket. It's all degraded thicket. We shouldn't be able to see any. There should just be a sea of green up there. This is, just remember, this is all alluvial vegetation down the bottom here. This is all acacia karoo. That doesn't get out of the river channels. That doesn't grow up. So you got to kind of look at that as, it's called azonal because it's not within the rainfall zone. It's got to do with the river channel. Anyway, I'll leave it at that. Cool. Cheers. Bye.